Good morning. All right, so today we are doing something very similar to what you've been doing the past couple weeks, only now we got to get comfortable with the language and the formalities of some of the stuff that we're doing. Now, where's my marker? We're going to be focusing today, some of us, on arithmetic and geometric sequences. Honestly, you've already worked with these sequences before, and you've just learned these sequences, so it's nothing new other than new vocabulary and some structure. Arithmetic sequences follows a linear pattern. There is a common difference. Keyword right there, common difference between each output. Okay? Be very, very comfortable with this language. So, for example, obviously it's constantly going up by adding 4 or subtracting. That's what it is. The bread and butter. You've already learned this. Now you just learned a new vocabulary today. Geometric follows an exponential pattern, and there is a common ratio between each output. So all that means is it's multiplying by the same number every single time. Now, for formalities, I got some examples right here of each, and it'll be pretty basic. I got to find a of 30, so that means I got to find the 30th output. So some language I want you to become familiar with is we got like, if you want to just do something like this where we got our table, and I want you to get comfortable with this language. This is always my x, this is my y, but this is also called my input, and this is called my output. Okay? Be comfortable with this language. Now, what I'm looking at here, this is the initial term, the first one I see, so this is my 0 term, my first term, my second term, my third term, so on and so forth. So what it's saying is when my input is 1 into whatever this equation is, my output, the answer I get from this equation, is 19. When my input is 2, my output is 13. So this follows an arithmetic sequence because I can see it's constantly subtracting by 6 every single time. So this is y, or let's use our language that we're familiar with, which is f of x is equal to, it goes down by 6 every time, that's what I recognize, and my initial term was 25. Now this says find a of 30, so that means I'm going to input, and this is where the language, like the formalities, may look a little different, but you've already been doing this automatically. So now we're trying to find f of 30, so what that means is, see this is x, there's my x, I put the 30 in place of x, and I solve. So I do negative 6 times 30 plus 25, and I do f of x is going to be my out, this is not my output, but my input, blah, blah, blah. Negative 180 plus 25, and f of x, my output when doing this, when I input the 30, I get a negative 155. That is all you got to do, but I really want you guys to focus on the language. Remember, this means find the 30th output from this input, okay? Output is the f of x, input is just the x, or the y. Down here I got another one for you, and I can see this one is following a exponential trend, all right? And how do I figure out what this is multiplying by? Well, I'll just take 12.5 divided by 5. Take 31.25 divided by 12.5, and you find the common ratio there is it is constantly multiplying by 2.5. Constantly multiplying by 2.5, just like such. So this says find the a of 10 terms, so I know that my equation is going to say f of x equal my initial, this is my very first term, and my growth factor is 2.5 to the power of x. This says find the output when the input is 10. Replace this x with 10, and I go ahead and I do it. So I do f of x equals 5 times 2.5 to the power of 10, and I've already used my Desmos calculator, which I want you guys using. When you input 10, you get 47,683.72. That is pretty much the bread and butter of what we're doing today. You'll get a lot of practice with this, and I will see you guys in class.